Hi, gentlemen. We'll start, everybody. Welcome to the 987th monthly meeting. This is the first one of our fiscal year. So we have a packed meeting today. We have three speakers, Mario, Justin, and Slav. The only request is that the time for the presentation is maintained within 20 to 25 minutes. So we'll give a 5-minute warning at the end, if you may. Richard, all yours.
Glenn is not with us tonight, so I'm on my own up here. Because we're not having an August meeting, Benno said I could talk twice as long as usual. But I'm not gonna do that. This is a cartoon that Glenn found, and so I thought we'd keep that up there, but that's all. It's just, he likes the cartoons to be there when we come walking up. That's all they're there for. And so it's click. Let's get right to it, because we've got some great speakers tonight, and I don't want to waste too much time here. Next slide, please, Benno. So as far as the planet roundup goes, the two big guys in the sky these days are Saturn and Venus. Jupiter is lost to the solar glare. Severe conjunction was back on June 24th. And for a few months now, it's not going to be very visible, except in the early morning skies. Mars continues to disappoint. It's still 1.8 astronomical units away. 5.2-inch disk, that's pretty small. Mercury's got an interesting apparition coming up. It was at greatest elongation on the July 4th, standing 12 degrees above the western horizon. Inferior conjunction is July 31st, and a better elongation will happen in mid-August. On the 19th, greatest elongation occurs at 18.5 degrees away from the sun. Now in August in the northern hemisphere, the ecliptic stands before dawn, pretty high. It's got a pretty steep angle, which will make it easier to see it. It'll stand about 16 degrees above the eastern horizon at sunrise. So if you like to look at Mercury, I mean, you can always try to find it in the daylight sky, but if you want to get up early enough to look at the east sky, you can see it in like mid to late August. It's quick, it moves pretty quickly. Anyway, let's go on to this is the next slide. Venus, again, try for naked eye observations. It's about -4th magnitude. That's pretty easy to pick out of the daytime sky. Greatest elongation occurred on May 31st. It's currently 43 degrees away from the sun. Saturn's rising about 1:30 in the morning. These are for currently now. As the summer rolls on, of course, these times get a little bit earlier. Saturn's relatively faint in the sky at magnitude 1.1 because the rings are only tilted 3.4 degrees to our line of sight this month. And the rings actually, when they're fully open, 26-ish degrees, they reflect a lot of sunlight, making Saturn a pretty bright planet. When the rings are very narrow, as they are every 15 years or so, they don't contribute much to the brightness of the planet, making it relatively faint. Neptune rises with Saturn. As a matter of fact, all summer long, it'll be within the same field of a finder scope. So if you've never looked at Neptune, or you'd like to look at it again, it should be a relatively easy object to find, even in your finder scopes. It's about 8th magnitude. Pick that up in a 50mm finder scope from a dark site. And there you go, it's together in the typical field of view. All right, so that's it for the planets. I was going to include Pluto, but I decided not to. Something that you may have never seen before and may be interested in looking at are Saturn transits. With the rings nearly edge on, we're experiencing now a series of Titan transits across the disk of the planet. And some of those actually have Titan's shadow crossing the disk of the planet. You know, every time Jupiter's in the sky, I like to send out information about the shadow transits of the moons of Jupiter. These guys only happen about once every 15 years or so. And the next series isn't until October of 2038. The next time we start to get close to passing through the plane of the rings. So here are the ones that are coming up in the summer. There's one more to go in September, but I didn't really have room for it. But as you can see, most of them begin really early in the morning. So you got to set an alarm clock and get out there. And some of them don't end until after the sun comes up. And that shouldn't stop you from observing these things. If you've got a go-to telescope, you can probably find Saturn in the daytime sky pretty easily. One trick is to grab Saturn as the sky is brightening and follow it into the daylight, if you want to do it that way. But since they're so rare, I put them up there, and I'll send out emails as we get close to each one of them to remind you that it might be a nice opportunity to get out and check it out. It's a pretty umbral shadow, so it's a well-defined shadow on the disk of Saturn. Now, of course, Saturn's disk isn't particularly large, it's a parent disk. So you need a telescope that can give you some magnification. So you can really kind of crank it up a bit and look at it. John?
How, so, yeah, how did the size of the shadow of Saturn compare to the size of the shadow of Jupiter's moons on Jupiter?
I want to say it's comparable. I think Titan right about now is about 1.7 arc seconds across. And so being a very umbral shadow, it's probably pretty close to that. They're visible.
Have you seen them?
I've only seen one once.
Okay.
Ever. I can't even remember how long ago it was. A long time ago. But anyway, I thought this would be a fun thing to get you guys up out of bed and, you folks out of bed and check something out you probably have never seen before and may not ever see again. Anyway, those are coming up. I'll let you know as we get close to them. All right, next slide, please.
Rich.
Yes.
So I'd heard of a potential collision on Saturn. Do you know if that's been confirmed?
I do not. I hadn't even heard of it.
It's been taken away.
Oh,
Marco Claude yesterday
gotcha.
told us that it was some type of error.
Gotcha.
What was due to collide?
It might have been a camera error.
I
Oh,
forget
yeah.
who had captured it, but there was a bright spot.
I thought it was like an asteroid strike in the atmosphere of Saturn, and we were looking for confirming observations. But
Yeah.
now they just think it was just a problem with the system.
Some sort of artifact, yep. Okay. Well, to keep with my new set of slides, I was thinking about the Apollo flights the other day, and I thought for the lunar highlights for this month, I wanted to offer up a couple of Apollo related objects to look at on the moon. And one of my favorite Apollo landing sites to look at is the Apollo 17 landing site at Taurus Latrobe. Now, see, I missed this, but it was my little letters I messed up. I didn't look closely enough at them. But if you look on the western shore of the Sea of Serenity. No, go back. Ah! There we go. No, one more back. Go back one more. Back.
Is that good?
And one more back. There we go. So on the western shore of the Sea of Serenity, this is Serenity here, this is Tranquility here. There's a little bit of Maria here, and that's the Apollo 17 landing site. If you crank up the magnification, they landed right here. That's North Massive, South Massive. These are the sculptured hills that if you're a fan of the Apollo missions, that's the scenery that you saw in their moonscapes when they were walking around the surface. And it's best seen under high illumination, but it's actually really easy to find that. It's pretty visible. So if you've never looked at Apollo landing sites, this is a great opportunity. From about 4-day moon on, like I said, better under high illumination, it's easier to find it. But that's one of the features that I'd like you to be aware of. The other one, if you ever watched the movie Apollo 13, at one point the actor portraying Jim Lovell looks out the window of the Apollo spacecraft and goes, Mount Marilyn. And a lot of people don't, I've been asked many times, where's Mount Marilyn on the moon? Or can you see it? And you actually can. If you go to the next slide, it's relatively nearby this. If you look on the western shore of the Sea of Tranquility, there's a little triangular mountain right there. That's it right there. And that's Mount Marilyn. It's Secchi Delta is the official name of it. So if you are, like I said, a fan of the Apollo program and you want to see some of these landmarks on the moon, there they are. So that's, I like to look at that. Again, very, very visible under high illumination. So a couple of lunar things you can go look at during the month. There are cool things to look at on the moon every single night, of course, but I just wanted to highlight these things here. Anyway, all right, next slide. Fun double stars. Two of them, while we're out there in the summertime skies, look towards Cygnus. 16 Cygni. 6 magnitude pair of stars, 40 arc seconds apart. I call them the golden double. They're up here. The arrow pointing to 16 is up here by NGC 6826, the blinking planetary. And I use the golden double as a stopping point, a jumping point to get to the blinking planetary. If you've never seen the blinking planetary, this double star makes it a pretty easy find. The blinking planetary is actually bright enough to see in most finder scopes. And the double star that you can see is actually really quite pretty. And it just happens to be along the way. So I wanted to include that. The other one to the lower left is 61 Cygni. STF Struve 2758 Piazzi's Flying Stars. They are a pair of K-type stars, 11 light years away. And the significance of, or the historical significance of 61 Cygni is they are the first stars whose distance was accurately measured by a parallax in 1838 by the astronomer Best. They are called Piazzi's flying stars because they have a large proper motion. And the feeling, Best's feeling was that if something with large proper motion probably means it's relatively close. And so it was one of his original candidate stars to measure with parallax. And so with these stars about 11 light years away, I call them wolf eyes because they look like a pair of orange eyes peering at you from the darkness.
Where are they on the map, Rich?
61 Cygni is right here, right there. And 16 is right next to the planetary up there. They're just, like I said, they're fun double stars. All right, next slide, please. So a fun variable star is Delta Cephei. And again, I don't think this is a really, you're not going to stand out in the yard and go, wow, look what that just did. It varies its magnitude a little bit, about a magnitude, but it's of great significance because it's the prototype star, the archetypical star of the Cephei variables, which are distance candles that we use to measure things that are relatively close to the Earth. And so it's in Cepheus. It's up there for all of us to enjoy. So I thought I would include that. And if we move on to the next slide, please. I'm getting into the June challenges. Glenn wanted me to run them out back to April, and I'm like, no, that's way too much time. So the June challenge is the Galaxy, the Draco triplet, NGC 59, 81, 82, and 85. And it's a relatively easy group of galaxies to find. It's well placed in the sky still. So we have some slides from members to show these off. So let me roll through these pretty quickly. Here's a nice image by Mario with lots of other stuff, lots of famed galaxies in there. Mario, you want to comment on this one?
Yeah, that's the one that was in Sky and Telescope just last month. And it's about a 4-hour exposure with the 32, 1 hour each of luminance and then red, green, blue.
Okay. Nice. Thank you. I think Doug's is the next one.
You probably should notice that the elliptical is interesting. It has shells, which means it's not an old elliptical. It had to have been a recent merger.
Okay, cool. This galaxy looks rather flocculent, doesn't it? It looks like a flocculent galaxy. Two of those are easy to see. One of them is a bit of a challenge, but the darker your skies, the better, of course. And so check those out. Doug's your image is next.
Now, this one's about 5 or 6 hours, 6-inch aperture, shot wideband.
Okay. And again, when you hear these exposure times, please don't think in your brain that these are impossible to see visible.
No, they only take multiple nights.
Yeah, these are pretty easy to find. They're pretty bright galaxies. At least two of them are. Next slide, please. This is Corey Mooney took this. I don't know if Corey's on.
Live stacking,
Oh, there you are. Hey, Corey.
a lot of fun. It's like watching a Polaroid develop. You can
Yep.
see it in the first couple seconds and it just gets clearer and clearer.
And this is with this 8-inch f4 Newtonian. Lovely picture. Beautiful. Beautiful. Next slide is Dave Giordano. Dave here? I don't know if Dave's here tonight.
Yeah, I'm online.
There you go.
Yeah, I needed some work on my framing, but yeah, this was over 4 nights, about 15 hours total, using the Celestron 8-inch Edge HD SCT and yeah, my one-shot color ZWO 294 MC Pro. So
Nice. Thank you. Well, I twisted it that way so that the orientation would be the same as the other photograph.
that's fair. Yep.
Sure. And then here's yours.
Oh, this is from a C star. This was my backup image. The one I tried was with the C11, but the tracking did not work, so
Okay.
I gave up and
That's a little C star.
little C star, 50
Nice.
millimeters. Yeah,
Got 50.
yeah, for 2 hours of exposure. Yeah,
With a 50 millimeter C star, right? 50 millimeter?
Yeah.
Nice. Crazy what those things can do. And here's Russell Cox. I don't know, Russell, are you here with us tonight? There they are. He had annotated it, so I didn't turn it. All right, next slide, please. So the July challenge is the NGC 6181. It's a galaxy in Hercules. Sort of pointed out where the big fat arrow is. The bonus is that NGC 6210, the Turtle Nebula, is nearby. And this isn't a great chart for showing where that guy is. But the turtleneck is right about there. Right about there. So if you go looking for that galaxy and, pick it out, you can always go to the turtleneck, which is a pretty easy planetary. I think Doug, we have a picture of it from you on the next slide. There you go. And this was I don't know why Glenn put your name as Paula there, but that's okay. But there it is. It's a little tiny galaxy, right? Pretty faint, right? Do you think? Doug?
Well, that is the wide field image.
Okay, it's a preliminary image. Okay. Well, there you go. The observer's challenge for August is Webb's wreath. Webb's wreath was first mentioned in Thomas Webb's 1894 Celestial Objects of Common Telescopes. Just like a single line. It says a wreath. The grouping is an asterism of 13 stars in Hercules. The brightest is HD 164922, 7th magnitude star, approximately 72 light years away. Appears to have 4 detected planets. There's a little blurb in the May Sky and Telescope issue by Stephen O'Mara. And here's where we find it. I like the lens finder chart better than mine, so if you could click to the next slide, that'd be great. And Mario, I think this is an image of yours. I didn't know it says Doug Paul.
No, that's not mine.
That's not who's.
No, that's mine.
That's yours, okay. And it's 11 arc minutes by 7 arc minutes. It's a wreath of, here it is right here, where you can see it. I kind of put a big circle around it, but that's it right there. I've never seen that. I've never actually gone and looked for it. It's relatively easy to find. If you remember last month's double star of the month was 95 Hercules. So you're not far off the beaten path. You want to go back and find 95 and then scoot up and look at Webb's wreath. I think it requires a bit of power because those stars are kind of faint, but it's relatively small. Like I said, 11 by 7 arc minutes, relatively tiny. So there you have it. What else do we got here? Next slide, please.
Wait,
Go back.
yes, please.
Please go back.
Where is it in the star chart?
It's right here. Right here.
I can't see you waving at the projection.
It's labeled in there as Webb's
Okay, I see it. At the zeta. Near the zeta?
Yeah.
Richard, let me add.
Thank you.
Rich, let me just add, you didn't put mine up, but you probably show it in another month. It's very funny. I was asked by Roger to just do a quick shot, which I did. And then Steve O'Mara calls me from Botswana and says he's put an article in Sky and Tel, and he needs a real deep image because there's 3 fake galaxies in it.
Yeah.
He wants to use the challenge. So I did a 30-minute figure. How deep can he use? He's only got a 4-inch down there. And I had to do a full hour exposure. The galaxies are 14th mag, 15th mag, PGC galaxies, and a third one, which isn't even on the charts because it's 19th mag.
Yep.
I don't know if he was hallucinating, but no one can see these.
Yeah, well, maybe he can see.
See, I want to see it's in the May issue of Sky.
Yep. Yep. It's
By the way, that's only a 30 minute exposure.
okay. I'm sorry if you can't see the writing on the chart. If you want to click, well, never mind. Let's keep moving forward here. And because we're not going to see each other until September, the challenge is a relatively difficult globular cluster, NGC 6540, located just above the teapot of Sagittarius. So a little bit low in the sky, but with some aperture and some dark skies, it might be a worthy target to try to spot. I was going to put my sky and telescope chart, but it was so busy with all of the different things you can see in this part of the sky, all the deep sky stuff. In this particular area of the sky, you can spend all night in Sagittarius looking at globular clusters and nebula all over the place. It's a fabulous place to hang out. So I highly recommend it. Now along the way, you might actually see this little guy. It almost doesn't even look like a cluster because it's in such a rich star field. It doesn't look isolated enough for me to call it a cluster. Maybe it looks differently in a telescope. I don't know. We're going to find out this summer. All right, next slide, please. So here are the clubhouse dates on the 25th and 26th, unless somebody's not going to go to Stellafane, one of the 8 members of the clubhouse volunteers to open the place up. I have it listed as closed just because most of the folks are up at Stellafane. But there's the schedule for the month. And again, Glenn and I are going to try and run an intro to the summer sky on August 15th from 8:30 to 10:30. That's a Friday night, at the clubhouse with a rain date the following evening. And I think that's the end of the observers report, I think.
Our big event. So we have three speakers today, Mario starting, Justin second, and Slav the third. So we have about 20 to 25 minutes. So if you can keep the timing within that, that'd be great. So everybody knows Mario here too. So Mario is a retired cardiologist and he's practiced at the North Shore Medical. He's a graduate of the Boston College and Tufts Medical School. He's a board certified internal medicine and cardiology and a fellow of both American College of Cardiology and American Society of Nuclear Cardiology. He served as an associate professor of medicine at Tufts and held numerous leadership roles in organized medicine, including president of the Massachusetts Medical Society and member of the AMA Board of Trustees. In 2023, he received the MMS highest honor, the Award of Distinguished Service. Mario is a passionate amateur astronomer and has built several telescopes, including the 32-inch relay telescope in Gloucester, Mass. And his contributions are many, and to say the least, the International Astronomical Association, International Astronomical Union named asteroid 13537 Mario Motta in his honor. So Mario, if you
Okay, that's fine. So what I'm going to show tonight is images from Florida and images from New Zealand. So that's why the title is Things You Can't See From Here. And I'll just give a quick backstory as to how this came about. 3 years ago, after I finally retired, I went to the Winter Star Party, which I was never able to go to before because I only have a limited amount of vacation time and I just couldn't get there. So I retired and went there for the first time. And it's amazing. Skies are dark, the Bortle too. There are, how many have been to the Winter Star Party? Okay, great. Skies are dark. And you have all these people driving down from northern states with really large rigs. They're all in trailers. And I'm talking, 20 to 30-inch scopes. They're all set up. And I'm going around. I didn't bring the scopes. I feel I just looked through others. Go to the first person. What are you looking at? M42. Okay. I go to the next one. What are you looking at? M42. After the fifth person was looking at M42, I was willing to pull my hair out. Because I said, why? I did. Yeah. I said, why are you looking at stuff you can see from home? Yeah. Well, give us some suggestions. So I started giving suggestions, and eventually that became the Winter Star Party list. Dianna Hannikainen thought it would be a great article, so that ended up in February of 2024 in Sky and Tell, and you can use that. All those pictures I took from my home in Naples. Then last October, I had the honor of being a keynote speaker for the Starlight Conference in New Zealand. And while there, I had the real pleasure of being able to observe with the former director of Mount John's Observatory. He has his own home, 14-inch. So I spent the entire night observing, me and Bernie Volz, who came with me. And I met this guy, Adrien, who does really nice work. His images are nice and sharp, but he really has no processing skills. And I told him that, and he agreed with me. So I took home a bunch of his subs, and since then he's sent me others, and I've been processing his stuff, and so we have a nice collaboration. So he's my Southern observer who sends me data. So I'm going to just go through these quick. It's more of a slideshow. You've seen this. My observatory, and this is what I've taken all the photos you're going to see from here, from Florida, I mean. C-14 on a Nioptron mount, C-70. It works very well. So this was in SkyTel, and it lists all the objects that were put in. A few of them you actually can see from up here, but they're low in the sky, and they seem much, much better when you're further south. I mean, a few in Eridanus, and a couple in Canis Major. Here's a list of the ones that are in the article. NGC 55. It's a large galaxy in Sculptor. It's 32 arc minutes long. So it's one of the largest galaxies in the sky, but it's really low in the sky. It's minus 39 Dec, so it's almost impossible to see from here. And it's 8 mag, and Robert Burnham calls it one of the outstanding galaxies in the southern heavens. It is. It's really worth looking for instead of M42 if you go to with the star party. The only thing is it sets early. So these are listed in order. The way I laid it out is when you set up and it first gets dark, this is the first thing you should see because it's going to be setting, and then just work across the sky till early morning. NGC 253, this you can get from up here. In fact, this is from the 32, but with color from Florida. I've learned a little trick. I can do really sharp luminance up here, but if they're low in the sky, they don't stay above the horizon long. You can't really do the red, green, blue unless you do 4 nights in a row. Rather than waste the time, I do the red, green, blue down there and combine them. Yeah.
Yeah, Mario, we've actually picked that up at the clubhouse in more than one night, but the conditions have to be just perfect.
Exactly.
Transparency has to be so good. It's so far south in Sculptor, is it not?
Yep.
Yeah, way down. I think they refer to it as.
No, 253 is in Fornax.
Oh, Fornax, yeah. Silver Pine.
It's actually large, yes.
Hmm?
It's large in the sky.
Yeah,
Making
it's
it more challenging.
29 arc minutes long, and
Low power for that.
it's in Fornax. It's 7 degrees south of the second magnitude beta CETA. But it's just a glorious galaxy. This one I like looking at in Florida. It's really a nice galaxy. And the other thing is, there's plenty of H alpha regions buried in it. 908, you can see some H alpha regions in that. This is minus 29 Dec, so it's a little further north than that, but it's just better from Florida. It's in Cetus, worth a look. It's 58 million light years away. 1097, this is one of my favorites in the sky.
Pretty good.
Well worth looking at. You can see this from up here. It's in Fornax, but it's in the northern part of Fornax. It's minus 30 Dec. So this you can catch from the clubhouse. Well worth looking at. But of course, the further south you go, like Florida or the Keys, it's much higher in the sky and you just visually see a lot more detail.
Is that one galaxy or two?
One. It's a distorted
Looks like there's 2 circle cores.
Yeah, I know. It's a distorted arc. See this here? That's a separate galaxy that went through it and it's distorted. So it's actually
So it is 2.
well, it's 2, but everything you see here is 1. Yeah, this galaxy apparently went through in this direction and it distorted the spiral arm. Yeah, it's fun when you take pictures and look at, I like abnormal galaxies because then you can do a little research and figure out why they're abnormal. Most progress in science is looking at the abnormalities, just like diseases in medicine. Okay, if you want to figure out what the function of an organ is or a particular cell, look for someone who's it's not functioning anymore. Now you can figure it out very easily, right? So it's kind of the same detective work. Now, this is one of my absolute favorite in the sky. This projecting as well as it is on my.
Yeah, the projector's washed out.
Yeah, I mean, this goes up to here on my screen and out to here. This is one of the most beautiful galaxies in the sky. 1365. It's minus 36 Dec. So again, you can get it from here. It's just really low in the sky, and it's 10th mag, Barred Spiral and Fornax. Now, what's unusual about this, again, look for the abnormalities. Anyone notice that there is a disk crossing right here? See that? Okay, so that tells you one thing. This is not a galaxy on edge. I mean, a face on like it wouldn't. It looks like it's a face on galaxy with splayed out arms, right? It's not. It's an edge on galaxy with a severely distorted spiral arm that should be out here, and another severely distorted arm, which actually goes out to here on my screen, that's been distorted. It's amazing how much distortion there is. It's not clear which, there's some other galaxies in the surrounding area but something really devastated this galaxy. And the clue is the dark disk crosses right in front of the core right there. So it's one of the most amazing galaxies in the sky. So when you look at it, and you can see this from the clubhouse, look for these details. Another one of my favorites. I love barred galaxies, and in the late fall, early winter in the Fornax region, there's a ton of them. Look at this huge bar, spiral arms, some distortion as well. Not clear why on this one. But this one's in Eridanus, and this is fairly easy to see from here. -19 deck, 10.4 mag galaxy. No difficulty seeing it. 65 million light years away. And you can see this easily in an 8-inch. 1291. Now, what's interesting about this, again, it's not projecting well, but it has a bar and an inner disc, and then it has an outer disc.
Turn down the room.
No, it's not a matter of the lights. It's not something wrong with the projector.
If you look up on the screens up above. you can
Oh, okay. Okay, if I point something out that's not on the screen, look up there. But, and there's fuzz around it as well. And that's, something's caused this, it's almost a ring galaxy where something's gone through it, but there's nothing nearby, so I have no idea why. But at least on my screen, there's a lot of H alpha dots on this outer ring. So something's causing a lot of starburst formation. I want to do this one in color for that reason. Maybe this coming winter. 1350 is another spiral, also in Fornax. This one's 87 million light years away. Has an inner bar and an inner and outer ring as well. -33 deck. This one's known as Halley's coronet. He noted this, that it had a spiral end that stuck out and a disc going across. And the reason for that is this galaxy here, which apparently has gone right through and distorted the rest of the galaxy. So it's 50 million light years away in Eridanus. And again, distorted by the companion galaxy. A lot of these are arc galaxies, by the way. This is an interesting one to look at. It's called Robin's Egg Nebula in Fornax. Notice how blue it is. It's fairly large and bright. It's only -25 deck, so this is a one again you can see from here. So I'm kind of lying on the title, but in Florida it's kind of up here. It's really nice to observe. The color comes through really nice. Even in a severely light blue, you use an O3 filter because it's all blue anyways, and it comes out really well. But this is a planetary nebula, and there's the dwarf star in the center. Rather large though. 1851. It's -40 decks. Now it's starting to get deeper. This is in Columba. Not going to be really well seen from here. Globular cluster directly south of Orion and Lepus, but it's magnitude 7.1. And again, you're missing all the fainter stars. All right, this is 2292 and 2293 colliding galaxies. They're small, but they're fairly bright. So you can see the -26 deck. It's a merging double galaxy in Canis Major. And they're 11th mag. They take high power really well because they're compact for 11th mag. And then as a bonus, you get 2295 from the same view. Now this one I know you've seen here, Thor's helmet. But this is with the 32. This has no Florida component in it at all. I just like it because that's one of the objects I put in for the winter star party to look at. All right. M46 has NGC 22437, a tiny planetary in it. Look for that when you look at M46. 2997. is minus 63 dec, so you're not going to see that from here. And it's a spiral galaxy in Antilla, magnitude 9.4. Visually, this I saw in New Zealand. Visually is very nice, and it's 3109, minus 26 dec, a large, irregular but faint galaxy, 19 by 4 arc minutes, so it's fairly long. And it's across the field in Hydra, just over the Antilla border. All right. GUM 15, which is minus 41 dec. It's 20 by 20 arc minutes, and it's in northern part of Vela. Really good with an O3 filter. I've observed it with that. It stands out really well. And just for those who don't know, GUM was a Australian astronomer who, just like we have the SH2 regions up north, he cataloged similar regions further south than SH2 regions went. So this is one of his, this is the 15th one he cataloged. But again, with all the GUM objects and all the SH2 regions, H alpha and O3 filters are really good. This one is, this one's GUM 15. What did I screw up? Oh, 2447. I'm sorry. Okay. Skip that. That's out of place. GUM 15, RCW 19, and this is another set of H alpha regions in the deep south. This one's in Papas. And it's 40 by 40 arc minutes. I took this with a one of my smaller refractors down in Florida. You got to use a wide field, and this with the H alpha and O3 filter. Rogers, Campbell, and White Oak did the that's what RCW catalog stands for, and it's things that GUM didn't find. This is one of my favorites. Just I like it. SH2 294. You can catch it up here. It's minus 9 dec. It's called the little octopus of Monoceros, right? To me, that's dinner. It's great. And here's a really nice, interesting site. This is these are all now in Vela, so getting further south. This is known as the Pencil Nebula or Herschel's Pen. This is more. It's a bright streak of light that's in the outer section of the Vela supernova remnant, which is down here. And this is kind of a shot front that's hitting some cool dark gas up here and just lighting up that area. But it's very striking when you see it, and it photographs really well. This was a narrowband filter imaging. All right, the Vela supernova remnant. To get this, you can't use the 14-inch or certainly 32 would be way too. You'd just be looking at a small area. It's a huge area of sky. It's the equivalent of 8 full moons in terms of size. So I used my small finder scope, my guide scope, and I put the camera on that, built a little adapter for it. And this was H alpha, sulfur, and O3 imaging over a course of 4 hours. But I like the way it came out. I finally was able to get almost all of the Vela Nebula. So this is one of my triumphs. It's again, it's not as, hope it shows up better up there.
Yeah.
Okay. Because I'm proud of this one. This one took a lot of effort. And this is another tiny, going back to the 14 inches. There are all these little segments like Herschel's wedge and this one off to the other side. Herschel's wedges were over here, main part of the supernova remnant. Here's another outer lying part. There's hundreds of these. All right, RCW 36, minus 43 dec in Vela. Use an O3 filter if you're going to look for it. Star forming region. RCW 38, minus 40 deck in Baylor. It's very diffuse and it's very large. You're missing all the fine stuff in between. Oh, well, it's just not projecting well. And, it's diffuse, and if you visually look at it, use an O3 filter. This is what I'm telling people at the winter star party. NGC 3201, it's minus 46 deck. It's very bright, 7th magnitude overall, 20 arc minutes across. So this is as big as the M13. And it's just as impressive, actually. All right, so at this point, past midnight, and at the winter star party, and moving on to things you can only see after midnight. So this is the Hydra cluster. It's only minus 27 deck, but lots of galaxies, and there's lots of faint ones which are not projecting well. But it's 140 million light years away. And despite being so far away, even in a smaller scope, you'll see these. They stand out because they're reasonably bright. So it's worth, that's why it's in the catalog. 3621 is minus 32 deck, and it's a 12 by 7 arc minute galaxy in Hydra. And this is one of my absolute favorites in the sky. How many people have seen M83? Okay. So the problem is getting the color here because it's low in the sky. So this is with the 32-inch, and even the color didn't come out as well as I like. So I got the color down in Florida and then processed it up here with the 32. Came out reasonably well. A lot better on my screen, the color, than it is over there, but the colors aren't showing up right. On my screen, at least maybe up there, there's lots of H alpha regions which are showing up. It's a very nice galaxy to observe. And this one of my absolute favorites in the spring sky or early morning sky in Florida during the winter months. 5128. This is again, you're missing some of the nice stuff out here, but this is a giant elliptical swallowing a edge-on spiral that's going right through. So remember I mentioned on the Draco triplet that the elliptical had ridges and concentric circles. This is what that's going to end up being. That's where it comes from when it swallows another galaxy. And this was discovered actually as radio noise. Everyone hears Centaurus A? That's a radio source. Turns out this is Centaurus A. Okay, it's the A is part of the catalogs for radio noise. And the reason of radio noise, this is only 12 million light years away, but it's the gas from the spiral is interacting with the gas of the elliptical, what gas it has left, and it's creating an intense amount of radio static traffic, and that's what you're hearing when radio telescopes look at this. But look at the disruption. I just love it.
Mario, what's the magnitude of 5128? Do you happen to have that?
Yeah. Minus 43 deck.
I mean,
It's magnitude 6.8.
I was gonna say, we saw that, picked it up on the Finderscope, the Texas Star Party, a number of years ago.
Yeah, it's
And
really
really
bright.
quite brilliant. When you look at that in a fairly large job, it's
Yeah.
very impressive. You see the dark lane.
It's so bright you can see it even.
And this is Omega Centauri, 5139. Again, an incredible object to look at. It's minus 47 deck. It's twice as big as the full moon. Incredible object. And we'll quickly Ian wave that. 4945. And let me just, I won't describe them. Let me just flip through the images. Sure. This is from New Zealand. That's Adrien Barrajon, who took images, and I did the processing. But this one I took from Australia, the Magellanic Clouds. Here is the center of the Milky Way. This is by Barrajon with a wide field lens on a camera. Here is the southern Milky Way, Zeta Carina, Southern Cross, and Alpha and Beta Centauri. It's a majestic sight if you can ever get to dark sky in New Zealand. I was mesmerized. The jewel box just inside the okay, this is 2018, which is this object here. I shouldn't have covered it right there, but it's part of the small Magellanic Cloud. It's a tarantula, which is part of the large Magellanic Cloud. Incredible star forming region. Here's a small Magellanic Cloud, and notice this object here, 47 Tucanae. Too bad it's so close to the South Pole, but I consider this the best, absolute, bar none, globular cluster in the sky. It looks like M15 because it's really condensed, but visually you see stars all the way out with this intense grouping of stars in the center. But you have to be in the southern hemisphere because it's only 10 degrees from the South Pole. Zeta Carina. That's Zeta Carina, and here's the keyhole. 55 from New Zealand, much better. This is 7552, which is in Grus. It's a quartet of galaxies, but the other one's too far out. You didn't catch it. I didn't take these, but I reprocessed these for him. IC 2944. This is supposed to be the running chicken. I don't see a chicken there. And this is 1763, which is part of the large Magellanic Cloud. This is one of my favorites, 2442. It's called the Snake and the Mouse. Some people call it the meat hook, but it's a very interesting galaxy. Again, the disk is distorted. It's not that this is face on. So you got two examples of that in the sky. 2818, which is I forget the name of it. It's called an egg, some egg, robin, not the other one's a robin's egg. But anyways, it's a planetary nebula. Another planetary nebula, 3918. I'm not giving you the decks on these because I got to go through these quickly. Other people want to get up and talk, but these are too far south for you and think of seeing it, even from Florida. This is 3199, which is called the Smile. Block there on the name. The other one was the blue planetary. Oh, it's called the Carina Smile, or the Banana Nebula. Just to give you an example, when he processed, all he got was this white area. In his imaging, he had all this other stuff, but he didn't know how to process it out. HDR processing brought it out. This is press. It's an open cluster. The heck was the name of it? I'm blocking the name. 3532. What makes it interesting is it's a field of blue stars and red stars in the same cluster. Okay, which is fascinating. 4945. 5189, which is an incredibly complex planetary nebula. None of this was visible in his. This is 6164, called the Dragon's Egg. The fighting dragons, except he missed them. They're down here But that's fine. It's still an interesting scope in 6744. Coming at the end here. And this is IC 5148, planetary nebula. It's called the flat tire. 7424. And this is Southern Cross, 1 degree above the horizon. So Southern Cross from Florida, winter Milky Way, and just love this planetary. I got this from Florida. You can probably get it from up here, 164 plus 31. It's worth getting for. I don't know why it doesn't have a better name. And this is my favorites, one of my favorites. You can get this from up here too. All right, I'll stop there because we got other speakers. All right, thank you.
Thank you, Mario.
Thank you.
So next is Justin. For the sake of time, I'm hoping that you'll be able to read all these details in the newsletter, the background of this work, and also Justin's bio. So I'll ask Justin to come and start the.
All right, that's a tough act to follow. So anyway, maybe next time put me before the world-renowned cardiologist and astrophotographer. My name's Justin. I've been an ATMoB member for about 2 years, and no, I do not have an asteroid named after me. So again, tough act to follow. All right, so after my 13th or 14th straight night of clouds a couple months ago, I decided to look at a quick YouTube video on an intro to radio astronomy. And the speaker in that video, Dr. Wolfgang Herrmann, said there are 2 types of people that do radio astronomy. One is an astrophysicist because they need to do that work for their studies and then for their job. And the second is optical astronomers who are sick and tired of the bad weather and want to see something, even if it's just a spectrogram. So I felt seen when he said that. I was definitely in that camp. And that was the motivation for driving me towards this project. So the title of this is Dipping My Toe in the Radio Astronomy Pool, Getting Imagery Directly from NASA Satellites. And just a quick, as I mentioned earlier, the spring weather really started to push me to the dark side, and this is my conspiracy theory time. I think we got some evil work here with Darth Sarah and Emperor Cloud Patine bringing in all the clouds, you know, forcing us into radio astronomy, or just be forced to stare at clouds for the rest of eternity. So you've been warned. All right, so this is what got me started. I had noticed this advertisement on Amazon for this package, basically a satellite kit or a satellite astronomy kit in a box. And it came with most things that you needed to be able to connect with NASA satellites. And I was initially skeptical. I thought you needed a ground station, you know, to get this sort of data. And my curiosity was piqued. So before I spent $200 on this package, I did a little research. There's, I think, 4 or 5 GOES satellites that are currently in geostationary orbit. I checked GOES 16 too low. I have very tall trees in my backyard, so I need something a little bit higher elevation. 17 and 18 still too low. GOES 19 became operational in April 2025. How convenient. At 41 degrees elevation from where I live, just above the tree line. If I put the satellite dish all the way at the north part of my property, because it orbits at 190 degrees azimuth, so pretty much due south. So I'm like, all right, 41 degrees I can work with. So I ordered the kit. Still skeptical. I have no idea what I'm doing, but I wanted to do something except stare at clouds. So I pulled the trigger, got the kit. It came with a software-defined radio, low noise amplifier, some RF cable, and other stuff to get me started. I still needed a little bit of hardware that I needed that I already had on my own, but it was enough to get me started and get to work. All right, so this is a quick look at the bill of materials. This is my setup in my backyard. You don't need the slide that you see in the lower image there. That's optional equipment. My kids use that. But what you do need, and which came with the kit, is that low noise amplifier that you can see there. I don't have a laser pointer, so sorry. Some RF cable, and then that feeds into the software defined radio, the SDR, which then feeds into my Raspberry Pi 4, that black box at the bottom. And all that black box is it's an aluminum container, and it acts as a passive heat sink because it can get warm, right? So that helps dissipate the heat. I essentially only have 2 cables going in. So at the right there at the top is the RF cable from the feed from the boom, and then at the bottom I just have power coming in. It's just the USB 5-volt cable, and that provides the power to the Raspberry Pi. And then at the bottom you can see the mesh antenna. So it came in a small box in 2 pieces. I just put it together, fastened the boom, which comes out perpendicular to the antenna, and I was up and running in pretty much an hour, at least from a hardware perspective. I still had to do a little bit of software work, but the hardware came together pretty quickly. I was surprised. So this is an exterior view. I mean, this is really everything. I have it all self-contained into one waterproof enclosure, again, because with all the rain we've had to make sure I kept the electronics dry. So I have it contained all in that enclosure, and then I have an extension cord running out into that black box, and then plugged in that 5-volt cable, which feeds right up into the Raspberry Pi. So a pretty self-contained solution that doesn't take up a whole lot of room in my backyard that my kids can knock over and break. So it worked out pretty well. So once I had everything together, I pointed it again at 41, around 41 degrees. I think it's 40.9 at 190 degrees azimuth. And once again, that just barely clears the tree line. There's some software that you have to install called Goes Tools. Very convenient open source software, free software. And I just install that like you do other software on Raspberry Pi as a package. And you have that all installed for you. That does the packet retrieval from the satellite and the processing of the packets once you have enough to create an image. If I had to do that on my own, I wouldn't be speaking here today because I wouldn't have a project. So I'm very thankful that software exists. And then, you know, from a whole loop perspective, you know, the signal comes in from the antenna, from the satellite, goes through the LNA to amplify the signal into the software-defined radio, and then into the Raspberry Pi where the processing of the software happens with Goes Tools, or excuse me, processing of the signal. And the output is really pretty phenomenal. I gasped, literally gasped the first images that came in. I was very surprised with a less than $200 system to get that sort of imagery in real time from a geosynchronous orbit satellite 22,000 miles away. To get that, it was just so eye-opening. All right, so as I mentioned earlier, I used the Goes Tool software, and this is just a couple screenshots of what you see. So on the top is Goes Receive. That's what receives the packet data from the satellite. It's just raw packets, so you can't really do a whole lot with it. The important variables there are the VIT, which you can see on the all the way to the right here. That's, I think it's called a Viterbi average. So that's basically how strong your signal is. And it's not intuitive. You want that number to be as low as possible. So if you're under 100, you're doing very well. Around 200, you're still okay. If you get above that, you're going to start to have drop packets. And then at the bottom is the Goes Proc, which is the processing of the raw data that processes those packets into viewable images, and you can see how it's writing individual files to the Raspberry Pi. So here are some sample images. These were the first 3 images that I got. Again, it was just so impressive seeing. These are cropped down into the New England region, but the first images you see are full disk. So it's, basically half the globe of the US and part of Western Europe as well. So just very impressive images. They have a collection of images based on the channels of the sensor that they have on there. That's called the ABI. I forget what it stands for, but there's 16 channels of data, and it looks at various different elements to be able to discern weather patterns. Right now, for my project, I only use one channel, but that's certainly a future capability to combine multiple channels together for better understanding of what the weather is doing. And then the full disk, I think it's just really cool. It's just a color image of the full disk of Earth, and it's just very impressive. And I have an animation at the end that shows what you can see from your backyard. All right, so it's one thing to just get the data, the imagery. I wanted to take it a step further and actually do something with it because that's where the real fun is, in my opinion. So I used a portal called Edge Impulse. I do some microcontroller AI as well in my spare time, and this is my go-to platform. It just makes it so easy. You input the data, you label it, you put in some parameters on what you want in your model. It trains the model all within its platform, and then you can deploy it quite easily, in my opinion, to a Raspberry Pi. So I used one of their proprietary models called FOMO. It's faster objects, more objects, and it's a 320 by 320 pixel RGB image. So a pretty good size. You can see it covers essentially, all of New England and more down into the Mid-Atlantic. So, I was able to get a good visibility of the region that I was interested in, and train my model based off of that area of the globe. So I used about 100 labeled images. For those of you who do any sort of AI stuff, more is better. So 100, I would say, is at the lower end. I'd certainly want to add more images for a more reliable model in the future. But a 97% F1 score, that's essentially accuracy. That's a pretty good score for even just 100 labeled images. And the picture at the bottom is just the Edge Impulse interface. All right, so this is an animated GIF that I had generated. This was May 23rd, 22nd and 23rd. And this was when we had the nor'easter that came. So these blue clouds are not necessarily rain, but they can be indicative of rain. These are really just cloud temperature differentials. So that blue, light blue and green indicates a temperature differential from the other clouds around it. So not 100% guarantee of rain, but certainly indicates the potential. And you can see the gray there, which is, just our regular cloud cover. So pretty neat to see it in motion, I think. And those green bounding boxes are, what the model recognizes as clouds. So again, with just 100 images, labeled images, it does a pretty good job of detecting where those cloud temperature differentials are. So the script so I did all my coding in Python. For those of you that do code, Python I think is pretty user friendly, I would say. And I used my own Python code to, again, crop the image to the New England region, run that model, detect the clouds, put in those bounding boxes, and then it creates an animation of the latest 30 measurements. So for this channel, it's one measurement every 30 minutes. So I think this should be around 15 hours of data. And then once I created this animation, I created a intranet Flash server so I could see it internally. And I also pushed that to an external web page as well. So I'll bring up a live demo in a second. All right, so anyone who does presentations, you're told to never do live demos, but I'm just going to go for it. All right. So, all right. So what we're looking at here is a live look at my Raspberry Pi. So this is live data that you're seeing on the left right here. So you can see those Viterbi numbers are in the 90s, which is pretty good. And then right here is the live data being written. So the VCID is the ID of the channel that they're getting. And you can download, since it's a NASA satellite, all this data is available freely, including a very detailed guidebook on what all these values mean. So that VCID of 25 corresponds to a channel. So right now it's downloading that channel. And once that channel is complete, you'll see, writing and then the name of the file. So it's always fun to watch this in real time. Just to see the data come in. It's still magical in my opinion. And then I just put up the commands here because it is not intuitive. So you gotta create a configuration file. So that's what that goesreceive.conf is. You gotta create a configuration file for the goesreceive command as well as the goesproc command. So it understands, what you're looking at, what your frequency is. But once you figure that out, it's smooth sailing. And then, all right, let's go to my webpage, see if it comes up. Great. All right, so this is essentially real-time data that we're seeing right now, starting from 15 hours ago, and then moving up till right now. So pretty neat again to see the activity that's happening, see the model working in real time.
Justin, what the satellite, what kind of detector is it? Is it infrared?
It's several different sensor types. So the name of the sensor is called the ABI. Again, I don't know what it stands for, but it's like multispectral. So it looks at several different things. 16 channels worth. So there's I think UV, IR, and I think there's a temperature sensor there as well to detect the cloud temperature. So several different sensors on there combined to produce this imagery.
Hi, Justin. Charles Wright here online. So you're showing this one area of just basically New England and surrounding, but did you crop that from a larger, and does that is it the particular GOES satellite coverage area that you're looking at, that you're basically stuck with? Not to be blunt about it, but.
Yeah, no, great question. So GOES 19 looks at half the globe, essentially all the US and Western Europe. So I just cropped to New England because I was interested in the clouds coming towards my area.
Got it.
But you can see the entire US, Canada, South America. Zooming out from that level, you can't see a whole lot from a resolution perspective, right? So that's why I cropped into New England and Mid-Atlantic. But you can really look at whatever area you want, including the entirety of half the globe.
That's great. Thank you.
Yeah, sure. All right, so again, it was a really cool project. End to end, it was probably 3 to 4 weeks total to get all the coding done and work out the bugs. But there can certainly be future capability as well. MWIN is an emergency management text-based system that's also relayed through the GOES satellites. So I can get that data as well. I haven't even tried to do that yet because it requires a different configuration file, but that's something that you could add as well in terms of capability. And then, as I mentioned earlier, you can do overlays of that different channels of data. I just used the cloud temperature one, but you could certainly look at other channels, combine that into a really powerful model for better prediction capability. And then I could also reuse the dish antenna for solar hydrogen line monitoring as well. But that get a little trickier. You'd have to do a little bit of tracking with the sun. I'd need a different boom because it's at a different center frequency of 1.4 gigahertz as opposed to 1.7. So there's a little bit of work that goes into that, but that's certainly something that can be done as well if I really want to geek down the radar astronomy rat hole. But that's something that can be done as well. I did write up a project on it. If you're interested, the link is there. So take a look. I have the code there as well, so you can look at the code if you're interested. So the kit is awesome. I've had a lot of fun with it. I thought it was going to be a big pain, and I was up and running for an hour. So the company did a good job. I think they're an American company too, Mlch. So they're local, and when I had an issue initially, customer service was great. So it was a lot of fun working with that. Ghost Tools, I mentioned earlier, if they didn't do that, I wouldn't be here because receiving the packets, processing the packets is a lot of work, and I wouldn't have been able to do that on my own in this short amount of time. And then as I had also mentioned, Edge Impulse, I use them for all my AI work. It just makes it so much easier rather than doing the TensorFlow lighter PyTorch.
What are you using AI for? What is this artificial intelligence component?
Yeah, so it's object detection in this case. So it's identifying the cloud temperature differentials and then placing a bounding box around it. So it's a type of image classification.
Is there a community of people besides yourself doing this?
Not that I'm aware of. I mean, there's some folks out there that do, connect to the GOES satellites, but it seems like a disparate network of individuals as opposed to a collection of. If it exists, I'm not aware of it. I've mostly seen just individuals saying, oh, hey, I do this too. So this is the full disk imagery that I was talking about. So Charles, to answer your question, this is what you see before you crop, right? For any of the channels, including the full disk, you see essentially half the globe. And what I did here was I just got the full disk imagery for 24 hours and then animated it. So it's, one full rotation.
So does it not work in the dark, or is this?
Well, this is a color image, right? So
Depends on the channel.
yeah, so color image, you're not going to see in the dark, right? But the other channels like, the UV, IR, you will, right? Any questions? Yes.
Yeah, so since this is SDR, you don't have to tune a specific channel, is that right? Can you decode all the channels in parallel or?
Yeah, so the only thing that I had to make sure that I had right in the SDR was the frequency, which is 1.6941. And then from there, the software loops through the channels through that configuration file and grabs the data for each channel of interest. So you can set that configuration file to do a subset of what you want to look at, or the entire array of sensors.
Right, I was just curious if they were sending all this data on parallel channels and you can only pick one at a time? Or?
It's serial. So, you're only getting one channel at a time.
Okay.
So it's,
That's the way they send them.
yes.
Okay.
Yep.
That makes sense.
But, since it is a NASA project, it's all sent in the clear. It's not encrypted or anything. So again, you just need to know where to point, know how to configure whatever backend you're using, whether it's a Raspberry Pi or a computer.
You need low trees.
Yes. Need line of sight. But at least for here, and this, if you're local to this area, GOES 19, again, it was just set to operational in April of 2025. So it's the latest technology. It's at 41 degrees. I'm in Concord. So if you're relative to that area, it's going to be around there as well. But yeah, I was pleasantly surprised at how cool it was. All right. Any other questions?
Well, I just wanted to point out, this is amazing. I have seen other projects. In fact, my students have done downloads from NASA and done real research on some of these images. There were open problems about this data. You don't have to repeat what other people have done. My students studied the detection of turbulence and air patterns, which is very similar to the machine learning you did for determining possibility of rain.
Yeah.
This is really cool. Also, there are a number of other satellites up there with very interesting stuff coming down. Some of them have completely open research
Yeah, yeah.
agendas. For example, the microgravity satellites.
Yeah, yeah. I think that the challenge with those is that I think they do polar orbits.
Mhm.
These do geo, so I don't need a tracking
Mhm.
mechanism, right? I could just
Hmm.
plop it to the ground and yeah.
Right. And also for those other ones, you would also need some community to write the SDR for you, unless you want to do that yourself.
Exactly. Yeah. So you need to get the packets, decode it, do that all on your own. Who has time for that?
My job.
All right. How am I doing?
I think we made time.
Awesome. All right. Thank you.
So the next speaker is Slav. He's going to talk to us about using night vision devices. So the details are right there. So he's going to do a show and tell of things.
We'll do this. It'll be easier.
Raise your hands who have seen the Barnard loop with your own eyes. Anybody? Your device, baby, sorry. It's the only way. Or the Horsehead Nebula. So that's kind of what we're gonna be talking about. So, okay. So this is the Barnard loop. And
You want me to move? You want me to?
well, I can probably just hit the arrow. Yeah, and this is gonna be a little low tech presentation. Hopefully it's gonna work out. So you can see the Barnard loop with that little thing. Yeah, and so what's the trick, or what's the mystery image? This is kind of like how first we're gonna talk about how the night vision works. Yeah, so you got the light from the galaxy far away hits the lens and the photocathodes. It converts the photon into electron. The electron is then sent down electrically charged tube called photomultiplier. Here the electron picks up more electrons, they multiply cascade, and then the whole heart of the electrons hits the phosphor screen in here. And that's kind of the trick, is the multiplication. The intensification, as they call it, happens in the electrically charged tube. One electron can generate 50,000 or more electrons. So you got, thick multiplication. Now, there are 72 such tubes per millimeter. And that's the limit, that's the limit, what is it? That's the resolution. The resolution of the eye. Yeah, so they got 72 tubes per millimeter, and that's kind of the technology. Let me see. Okay, in here, so this is the night vision device. Here is the front lens, and in here are the tubes. Yeah, and you got thousands of them, and they multiply each of those of the electrons, then it hits the phosphorus screen, and then it goes to your eye. Now, gone are the times of the well-known green view of earlier night vision generations. This is what they used to look, and this is how they look now. Yeah, it's basically it's white. So when you're looking through today's night vision device, you see black and white image. And since at night, your eye only allows you to see black and white, looking through the white phosphorus night vision device at night looks sort of natural. Now we're gonna talk about what type of night vision devices are there. So this is one type. It's called night vision micro. So it's a very tiny, it's smaller than this, it's very tiny. The problem is, if you get this, you cannot control the gain. So that's not very good for using it for astronomy, because you want to control the gain. Otherwise, you're gonna get the scintillation and stuff. Then this is called PVS-14. Teleview pushes this. The problem with this device, you can only use it in afocal mode. I'm going to talk more about this later. Then we got this is the typical night vision. This is called PVC-7. Again, you can only use it for afocal use. And then we got this. This is called Mott 3C. So this is like a very modular device. That's what I got. You can use it any which way you want. And I'm gonna, okay, so the easiest way is to place your night vision device directly into your telescope. Basically, you place the night vision sensor in the focus point of your telescope. So this is the night vision device. Then you get an adapter and you place it in the diagram. Yeah, that's this mode is called prime focus. The built-in focal length of the night vision is around 25 millimeters, and it has 40-degree field of view. So when you use it in prime focus, you only get one magnification and one field of view for any given telescope. You can mitigate this with barrels and focal reducers, but that begins to complicate things. You will likely get vignetting and the whole setup gets bulky and heavier. So there's always trade-off, but you can just take the device, plug in the telescope, and off you go. That's the Mott 3. With the other devices, you have to use them in so-called afocal mode. So you can attach the night vision device to your eyepiece. So this is the eyepiece. Yeah, this is Teleview 55 millimeter fluorescent, and you can take the night vision device and you can attach it to it. That's called afocal. It's not in the prime focus. So you attach it to eyepiece and you slide the eyepiece to the telescope. Yeah. Now you can change the focal length of the device. Basically, it's based on the focal length of the eyepiece. So you can change the magnification and the focal length in this setup. That's the advantage of it. The disadvantage is it gets bulkier. Yeah. And this is how it looks in a small telescope, so 60 millimeter, and you stick the television eyepiece into it, and then you have the night vision device on top of it. Yeah. But in here you can do different magnification. Also, you can use the night vision, the Mott 3, without telescope. So let's look at this. I go here. Okay. So I don't know. So in here, what I did, I bought an adapter to this is what is it, Canon lens. So you can buy an adapter, you can hook it up to Canon lens. So now you can use any photo lens you have. You can use it with the night vision device. So you get different magnification, you get different field of view. It's just based on what kind of lens you hook it up to. Yeah. So you can do all, as you can see, there's all kind of stuff you can do with it. Yeah. And so basically it just depends on your magnification. So this is the device. This is the Mott 3 device I choose, and I choose it for the versatility. I can use the afocal again or in prime focus. It can also be attached to the C. Okay, it can be attached to C-mount kind of camera, and that turns out to be a huge advantage. See. So this is the night vision device, and here is C-mount type lens. Yeah, this is, what is this, 25 millimeter C-mount lens. So you're gonna get one-time magnification with this C-mount lens, which means you're gonna get 40 degrees field of view. Yeah. Then you can use, this is 75 millimeter f1.1.8 C-mount lens. So in here, you're gonna get 3 times magnification. Yeah. So you can take this basically, this picture right here. And this is my favorite. And so 3 times, you just take it and you can pan around the sky and look at stuff. Yeah, you cannot get much better. And yeah. So let me see. So that's, yeah, I said that. So this is like 3 times, you can do 1 time. So you can, yeah, there's so many possibilities. And in here, I got it in one of my books. So this is like a helmet, and you can mount 2 of those devices on a helmet, and you can just go around and look at the sky. Yeah. So, and in here, this is the earlier version of what I got here. Again, I took Canon lens, EOS to C mount adapter, and you mount the night vision on it, and you mount it on a little mountain. You can basically observe it. So let me see. What else we got here? Or you can just use it as, again, with a telescope. Yeah. This, okay, let's see. So if I use it with this refractor, I get 4 degrees field of view and 30 times magnification. Okay, let me go back. In here, I got 8 times magnification and 5 degrees field of view. In here, I got 13 degrees field of view and 3 times magnification. So you can see I can choose pretty much whatever subject I want to look at. I choose the lens, and I can frame the subject in the, yeah. In here I got, this is 100 millimeter telescope, so I got I got like half a degree. I got like 1.5 degree and 30 times magnification. So that gives me like a narrow field of view. So that's this. Then, okay, in here I got the night vision device, and this is like a 2-inch setup. Yeah, so I can use this now as a regular 2-inch eyepiece. Yeah, so what do I do with that? I put it in my dock. This picture is better. This is my dock. Yeah, this is the focuser, and this is the night vision device. If you can see it. Yeah, so you can plug it into your dock, and I got my dock is f3.3. So that gives me 90 times magnification and field of view of half a degree. But I can also use my dock with the afocal setup. Yeah, it is the teleview lens. It is the night vision device. I plug it into my focuser on my dock, and now I can get 1.5 degrees field of view at 27 times. So I'm pointing all this out because you got all kind of flexibilities with it. Yeah, and okay, so this is like the different setups, and now what do you use the night vision on? That's kind of like that's the question. This is let me see it. Okay, so do you use it on double stars? No. Do you use it on planets? No. Open clusters? No. How about global clusters? yes, you can enhance them with night vision, and all of a sudden, you see a lot more stars in global clusters. Galaxies, yes, the faint ones pop up, and you see more structure in the bigger and brighter ones. Planetary nebulas, again, yeah, night vision enhances planetary nebulas, so you can see different structures in them. Comets, some people claim success seeing comets with a long pass filter, but I tried on 2017 T2 comet and with a disappointing result. So where the night vision really rocks is the emission nebulas. The invisible becomes visible by using narrowband HR filters. It's like Imagery. In my opinion, this is why you buy night vision device, to look at those H alpha nebulas. Yeah. This is California nebula. So but yeah, this is not night vision. I don't take pictures, so I pick up the pictures on the internet. So anyway, the night vision works in visible and in infrared region of electromagnetic spectrum. So the 628 nanometers is perfect wavelength for it. I use 3.5, 5, 7, and 12 nanometer HR filters. So again, they're like narrowband filters, and that kind of brings the nebulosity and stuff out of it. Also, night vision likes fast focal ratio systems. I mean, really fast. Like over there, I'm at 1.8. Yeah, using my using the Plausill, the Telebu Plausill with 67 millimeter focal length adapter gives me converts my f3.3 dot to like f1.2. Yeah, and that's in here. Yeah, Telebu cells. This is 55 millimeter Plausill. They have a converter which converted into 67 millimeter, so you can get even wider field of view. And then you got the night vision and filter H alpha filter to it, and you got 1.5 degrees focal ratio 1.2. Let me see. Okay, so you buy them now. You get the night vision device, and you need some accessories. So for handheld like this, you're gonna get the lens and the filters. You can screw them right here, or you can put them anywhere. But I like to mount the filters in front of the lens, because then you don't have to deal with the cone of light. With the fast lens, you get a cone of light. So you need filters. You can get long pass filters when you're observing like in light polluted skies, so you get rid of some of the light pollution. Or for the nebulas, I use it for 95% for nebulas. You need the narrowband filters. Yeah, and if you use it with the telescope, then those are the okay. So if you use it with the telescope, you need again the eyepiece and some adapter. Telebu sells the adapter. This is the Telebu adapter, which goes from the night vision to their eyepieces. Yeah, they want to. Yeah, they want to make sure that you buy the eyepieces. But that's so okay. So in light polluted skies, what I got here. So I got this is some of my photos. 3.5 nanometer H alpha, 5 nanometer. Yeah, this is 7 nanometer. This is 12 nanometer. Okay, now in here, this is the methane filter, 685 nanometer. You can use it for methane, and you can look at I look at Jupiter and Saturn, and you can see the bands of methane in those planets. Yeah, so you can. And then in here I got see, this is a long pass filter, 642 nanometers, and I'm sorry, this is the methane filter, I'm sorry. This is the long pass, and this is the methane at 889, so basically 900 nanometers. So you need some filters, and based on the filter, that's how you use it. Yeah, like I said, this is my favorite filter, H alpha 5 nanometers. I use it most of the time. Okay. So now, okay, this is, you know what this is? Yeah, this is the Horsehead Nebula. And so the ever elusive Horsehead Nebula. I pointed my dot on Horsehead Nebula using regular eyepiece. It was 70 millimeter ethos and H beta filter. I could not see anything. So I switched to night vision with H alpha, which is basically the same. It works out to be the same like the 17 millimeter ethos. Bang, here it was. So now I knew what to look for. So I switched back to 70 millimeter ethos with H beta filter, and I began to see the Horsehead Nebula with just a regular eyepiece. But it was, and I know that I'm looking at Horsehead because it was like a reverse image. The night vision gives you true image, the eyepiece gives you like a mirror image. Yeah, so night vision helped me to see the Horsehead with my own eyes through regular eyepiece. Yeah, it was kind of like a helper. Yeah, so it showed me what to look for, and I look at it, and I could see it. Yeah, and it's with Horsehead, it's amazing because you're looking at it and you can't see it. Yeah, you really have to. People tell me, I'm like, what are you talking about? But it's true. Yeah. Then, oh, that's a question.
Yes, Slav, you had it out at the clubhouse one night where we were looking at the Horsehead Nebula directly. Was it an H alpha or H beta filter?
H alpha. I'm probably confused. Use H beta with a regular eyepiece.
Right.
So I have it set up as a regular eyepiece with H beta, and I couldn't see it.
Right.
Yeah.
And you got a 22-inch dot.
Yeah, it might have. Yeah, we can try it in the clubhouse too.
Right.
But I could see the Horsehead with the night vision, and then I knew what to look for, and I could slowly see in a regular eyepiece with H beta. It kind of like it helped me find the Horsehead with regular eyepiece. So you don't have to you don't have to use. I'm just giving you an example. You don't have to use it only to look at skybar as a help.
Right.
Yeah.
Well, when we were using it for clubhouse in the
H alpha.
several of us, Rich, I think
Yeah.
you were there.
I was there.
The Horsehead jumped out at us. I
Yeah.
mean, you didn't have to use it for
Yeah.
vision. It was there. It was
Exactly.
like an astro image. It really was.
Yeah.
And previously, a number of months before, we were looking, I think it was the same setup without the filter. You had a 12 millimeter Nagler eyepiece. We were looking at the Deerlick, that's NGC 7331 in Andromeda, referred to as a Deerlick group. It has three companions. One is 7335. Normally they are invisible, and I mean invisible. Even in the 25 and a good night, all three jumped out at us visually, instantly. It was really impressive, really impressive.
Well, the same night, you let me look through the handheld.
Yeah.
thing. At Barnard's Loop, the Rosette Nebula, the California Nebula, they were just leaping out of the sky at me. It was the most incredible thing.
Yeah. That's the thing.
Every H alpha area I knew
Yeah.
was just like, oh my gosh, look at that.
The 1X or 3X is magical, like feet on the ground,
Yeah.
looking up at a familiar sky.
Yeah.
all the
This
magic.
is basically right. Yeah. And you just look around and.
Just don't drop it.
Last Monday, I said to somebody, last Monday I was actually observing with that because the moon doesn't really bother me if I'm looking at nebula. So I was looking at nebulas for a couple hours. I just but some people say it's kind of that it's not real. It's not a real thing. But when you're looking through it, then you feel like you're looking through.
Look pretty real to me.
And it helps you. It helps you find stuff. Yeah, and so, again, all this stuff, is it worth it? it all depends on what you're interested in. Yeah, I'm a nebula guy, so it works for me. However, if you're into planets, then you're better off spending your money on a nice refractor. Yeah, but as I said, it rocks in H alpha. Yeah, and I think I got some. Okay, so I got some examples here.
I'll turn the lights back off.
Yeah. So this is kind of like, this is what you see. Yeah, but you see, this is red. It's black. It's black and white. This is what you basically see through that thing. Yeah, which is amazing. I mean, it's popping up at you. This is the North American and Pelican Nebula. Again, this is, I don't know why it's red.
It's not right on the screens up above.
Yeah, it's black and white. Yeah.
That's the projector. It's the
Yeah.
same thing Mario was
So,
complaining
because
about.
I don't want to confuse people, you're not going to see colors in night vision. You see black and white, but this is basically what you see. Yeah, California Nebula.
Slav, I couldn't believe how big the California nebula actually was.
Yeah.
Yeah.
This is,
So I showed it,
Yeah.
huge.
you can, yeah, this is Vela Nebula. Yeah, you can see it. Yeah, this is the horsehead. Yeah. Yeah, again.
Yeah, look at the screen.
Yeah, you might, yeah. Yeah, it just. And this is, I believe, what is it, M82, M81?
Yeah.
Yeah, that's what it is. What we got here? Then we got the little triplet. And this is M51. In galaxies, you can see more structure. I mean, you can see it in your telescope, but you don't see so much structure. It kind of brings out the structure of the galaxy. Yeah. But again, in the light polluted skies, it's intensifying the light pollution as well. But you need to use the filters. Yeah. That's why the nebulas are. This is what is it?
A91.
Needle. And this is how globular clusters look. Yeah, you can see a lot more stars. Yeah, and this is So, but again, you're better off with nice refractor. Yeah, but with night vision you can see a lot more stars. And then globulus, if that's what you're looking at. Yeah, and I think that's the end of my So, any questions?
Yeah, these things must have a power source. Is there a battery built
Yeah,
into accelerate the
Yeah,
electric?
you need battery to run the multiplier. Yeah.
So is that like rechargeable? How long does it last?
It lasts forever. I mean, you buy like a little battery, you stick it into it, and I replace them every few years because the batteries, I don't know how long they will last, but I got some.
Pretty efficient. It's
Yeah.
supplying electrons.
It's very efficient. I mean, it's amazing. Yeah. And the device itself, the lifetime of the device is like 10,000 hours. Yeah, but I'm not gonna live long enough. Yeah, because I use it maybe a couple of times a month for a couple hours. Yeah, and so it's gonna.
And you talk about which generation?
This is the latest, the third generation, the white phosphorus. Yeah, that's kind of
That was the difference I noticed. The old generation stuff, they used to have the I3C columns. That was popular for a while.
Yeah.
But they had a lot of objectionable green. It was the phosphorus that kind of came.
But this is phosphorus, but this is white phosphorus.
This is white though. I mean, it's a good color balance when you look in real time. It deeps down.
And with the Mlch 3, you get like you can adjust the gain. Yeah, and so when you really crank up the intensification, you begin to see the scintillation. You begin to see, like in photos, the white noise and stuff. So you can down tune it. That's why you want to kind of control it. Yeah. So, but it's better than the older generation. There was a lot more scintillation. Yeah. So they're getting better. But, again, yeah, the problem is like in here. Well, you see what, this is H alpha, this is 5 nanometer H alpha filter, yeah? So you know, you really want to filter it, and that's what, this is dedicated to emission nebulas. That's it, you know, that's what, if I look at double stars, I use my refractor, yeah? I look at galaxies, I use my big deal, but it's, I have to just take it and you go around and like a little P finder here, just, but, yeah, that's. So,
Very cool. Thank you.
so it's one, yeah, I look at it as an eyepiece, yeah, this is just one eyepiece, yeah. Use it.
600. Thank you.
There we go.
So I think we have reached the end of the meeting, so we will see you next after a wonderful summer ahead. Oh, yes, telephone. So September 11th, 8 p.m.